This question belongs to computer network subject and was asked in GATE CSC 2015. So it states, consider a LAN with 4 nodes. So we have S1, S2, S3 and S4. Time is divided into fixed size slots and a node can begin its transmission only at beginning of a slot. So we have certain slots and a node can begin, this is our timeline, and a node can begin transmission only at beginning of a slot. The probabilities of generating a frame in a slot by S1, S2, S3 and S4 are 0.1, 0.2, 0.3, 0.4. So our probability of generation is this. So probability of not generating is Pg dash is 1 minus Pg, which is 0.9, 0.8, 0.7 and 0.6. The probability of sending a frame in the first slot without any collision by any of these 4 stations is. So we need to tell what is the probability that here any of them will be able to send the frame without any collision. So probability of sending means either S1 will be able to send, or S2 will be able to send, or S3 will be able to send, or S4 will be able to send. Okay, now if S1 is sending, then S2 and S3 won't send. So if S1 is sending, then S2, S3, S4 won't send. Or if S2 is sending, then S3, S4, S1 won't send. Or if S3 is sending, then others 3 won't send. Or none of them will send, only the last one will send. So we have to sum it up. So P of S1 means S1 is sending with a probability 0.1 and all 3 are not sending with probability 0.8, 0.7 and 0.6. Plus S2 is sending means it is sending with a probability of 0.2 and others are not sending with probability 0.9, 0.7 and 0.6. S3 is sending means it's sending with a probability 0.3 and others are not sending with probability 0.9, 0.8 and 0.6. S4 is sending, which means it is sending with a probability of 0.4 and others are not sending with probability 0.9, 0.8 and 0.7. So probability of at least one is sending and is exactly one is sending without any collision in the first time frame is, if you sum it up, you will get 0.4404. So answer is 0.4404.